Hello everyone. Today I'm starting this chapter, that is trigonometry, in the 10th class textbook AP Telangana. That is 11th chapter in your textbook. So I already explained this introduction part before. So I'll start from this. Do this, okay? I already explained this, all the explanation part, introduction part of this chapter for the students. So in the page number 271. I am starting from this 271. Okay, it's all the chapter about this triangle which makes 90 degrees, which has a hypotenuse, opposite side and adjacent side. So let us discuss these examples in this chapter. Okay, so the first of all, in page number 271 we have do this. Okay, we have do this. The introduction part of this chapter I already gave to you. So look at here. So identify hypotenuse, opposite side, adjacent side for the given angles in the given triangles. The first one, in this first one, so we have one triangle and PQR, and 90 degrees is at Q. There is an angles of this P and Q. For angle R, what is hypotenuse, what is opposite side and what is adjacent side, we have to identify. Okay, so for angle R, hypotenuse never changed, right? Hypotenuse is same for all the right angle triangles, it will not change, but this opposite side and adjacent side may change according to their angle. Okay, hypotenuse is equal to, what is hypotenuse? Here is the longest length of this right angle triangle. So and opposite to this 90 degrees and 90 degrees, that is PR. PR is the hypotenuse. Next, opposite side for angle R. What is the opposite side? PQ. PQ is the opposite side. What is adjacent side? Adjacent side, that is equal to, the adjacent side is QR. That's it. Here it is the first solution for this first sum. Second, we have to identify that the triangle which is given like this and the 90 degrees is here. Look at here, 90 degrees is here, Z, X and Y we have. So first of all we have to write the first, he was given that for angle X we have to write these three sides, and for angle Y also we have to write this three sides. So first of all, for angle X, so according to angle X, what is hypotenuse opposite to this 90 degrees? That is, hypotenuse is XY. Opposite side to X, opposite side towards X is, so opposite side of angle X is YZ. Adjacent side, the remaining side. Okay, adjacent side is, what is remaining here? XZ. Okay, just like that, for angle Y also we have to write angle Y. Okay, is hypotenuse changed? No, that is XY. What is opposite side for angle Y? For angle Y, opposite side is XZ. XZ. What is adjacent side? The remaining side, that is YZ. That's it. Okay, here we finished this. Do this. Look at here. Try this. Write lengths of hypotenuse, opposite side and adjacent side for the given angles of a triangle. We have to write the lengths of the hypotenuse, opposite side and adjacent side. So try this in same page, page number 271. So in this, given that the triangle is Look at here. So here A, B, C, and at B we have 90 degrees, and hypotenuse is given that is 5, and height is 4. Okay, we have to find out this one first. Okay, let us write A, B, C, 90 degrees, 5 centimeters, that is hypotenuse, 4 centimeters, and we have to find out this one. Okay, firstly, what he was given for angle C. For angle C. For angle C, hypotenuse is, this is angle C. Hypotenuse never changed, that is opposite to 90 degrees, that is AC. Hypotenuse is equal to AC, that is equal to 5 centimeters. What is opposite side? Opposite side means like here, AB. AB. Is AB we know? Don't know, right? So when you took any right angle triangle, by Pythagoras you can find out the remaining side by using of this theorem, Pythagoras theorem. By Pythagoras theorem, what we know, that is AC square is equal to AB square plus BC square. That is AC square is equal to 5 square, that is equal to AB square is we don't know, plus BC square is 4 square. That implies 5 square means 25 is equal to AB square plus 16. That implies 25 minus 16 is equal to AB square. That implies AB square is equal to 9. That implies AB is equal to square root of 9, that is equal to 3 centimeters. So we know that by using of this Pythagoras theorem, we find out this AB. Okay, 3 centimeters. So what is AB here? 3 centimeters. What is adjacent side for this BC? That is equal to, what is BC value? 4 centimeters. Second sum in this, for angle A also we have to write like this. So for angle A. So is hypotenuse changed? No. AC, that is equal to 5 centimeters. Opposite side, that is for this A, what is opposite side? BC. BC is equal to 4 centimeters. Adjacent side, that is equal to AB, that is equal to 3 centimeters. Here we finished this given sum. Okay, so after this, try this. We have trigonometric ratios. The trigonometric ratios I said to you, that is sine, cos, tan, cosec, sec and cot. These are the ratios of the opposite side, adjacent side, as well as the hypotenuse of these right angle triangles. We are making some ratios of these sides of this right angle triangle, then we get the 6 trigonometric ratios. Okay, 6 trigonometric ratios. By using of these trigonometric ratios, we have to write this like this: A sine A is equal to opposite side by hypotenuse, cos is equal to adjacent side by hypotenuse, tangent opposite by adjacent side. Just like that you have to make the trigonometric ratios of this 6. Okay, next we have 274 page. In the page number 274 we have do this. Okay, in this do this you have look at here, find sine C, cos C and tan C in the adjacent triangle. Here we have one triangle. By using of this triangle we have to find out this sine C, cos C and tan C. Let us draw this picture in notes, and page number 274 do this. Okay, so here in the first sum we have one triangle, that is A, B, C, right angle is at B, and we have angle, that is C, 13 centimeters, that is hypotenuse, and 5 centimeters BC. Okay, so we have to find out this side first, then only we will write the values of this sine C, cos C and tan C. Okay, So to find out this, here given that AC is equal to 13 centimeters, BC is equal to 5 centimeters, AB we have to find out. Okay, here it is a angle B is equal to 90 degrees. So in figure, triangle ABC is a right angle triangle. Right angle triangle. So hence by Pythagoras theorem, we have AC square is equal to AB square plus BC square. That implies AC square 13 square is equal to AB square, we don't know. So just write the same. BC square is 5 square. Okay, that implies 13 square means 169, that is equal to AB square plus 25. Okay, so that implies AB square is equal to 169 minus 25. That implies AB square is equal to 144. That implies AB is equal to square root of 144. That implies AB is equal to square root of 12 square. Square root cancelled. So AB is equal to 12 centimeters. Okay, so AB we got here. So what we have to find out, the first one is, in this first one is sine C. What is sine? Opposite side by the length of the opposite side by hypotenuse. Okay, what is opposite side of the sine C? Opposite side of sine C is AB. AB by hypotenuse is AC. AC. That implies, what is AB? We already find out that value, that is AB is equal to 12. 12 by AC is 13. That's it. So second one is cos C. That is nothing but adjacent, the length of the adjacent side by hypotenuse. That is equal to, what is adjacent side for sine C? That is BC. Okay, BC by AC. That implies BC is 5 by AC is 13. That's it. Here we have the value. And the third one, that is tan C. Tan C. Tan C means the length of the opposite side by the length of the adjacent side. That is equal to the length of the opposite side for sine C, that is AB by BC. AB by BC. That implies 12 by 5. That's it. Here we have the values of this values. Okay, next in second sum. In a triangle XYZ, angle Y is a right angle triangle. Right angle. XZ is equal to 17 centimeters. YZ is equal to 15. Then find the sin X, cos Z, tan X. We have to find out these values. Okay, first of all we have to draw the right angle triangle according to the given values. Okay. So second sum, first of all you have to draw one picture according to the given values. So here 90 degrees is at Y. 90 degrees is at Y. Why? Because angle Y is right angle. Angle Y is right angle means 90 degrees has to write at Y. Okay. The remaining two you can write anywhere. Okay. That is X, Z. The value of this X, Z is 17. The value of this Y, Z is 15. So it was not given. X, Y we have to find out. So given that, what he was given? Given that triangle XYZ is a right angle triangle. Right angle is at Y. That is angle Y is equal to 90 degrees and XZ is equal to 17 centimeters. YZ is equal to 15 centimeters and XY is equal to, we have to find out. So here it is a right angle triangle, hence by Pythagoras, what is hypotenuse here? The hypotenuse is xz. Xz is the hypotenuse. So xz square is equal to xy square plus yz square. So xz square is 17 square, that is equal to xy we have to find out, we don't know, plus yz 15 square, that in square 289 is equal to xy square plus 15 square 225. That implies, so 289 minus 225 is equal to xy square. That implies when you subtract this 225 from here, so you will get, that's it, xy square. That implies xy is equal to square root of 64. So that implies xy is equal to square root of 8 square. So that implies xy is equal to 8 centimeters. What we have to find out in this sum? So the first one is sin x. Sin x. Sin x, it is nothing but opposite. The length of the opposite side by hypotenuse. The length of the opposite side by hypotenuse. According to the x, what is opposite side? Yz. Yz by xz. Yz by xz. That is equal to, what is yz value? 50 by xz value 17. That's it. The second one is cos z. Cos z. Cos means the length of the adjacent side by hypotenuse. Cos z. According to the cos z, what is adjacent side? Yz by hypotenuse. Yz by hypotenuse is xz. That is equal to, so yz value is 15 by 17. Third one, tan x value. Tan x, the length of the opposite side by the length of the adjacent side. According to the x, so opposite by adjacent. Opposite is yz and xy. Yz by xy. What is yz value? 15 by xy value 8. That is the answers for this question. Next, third question. In a triangle PQR with right angle at Q. With right angle at Q. We have to draw the picture for this. Okay. So look after here. Third sum. So first of all, you just draw the picture of this PQR. So right angle is at Q. So P and R you can write anywhere. Okay. The value of angle P is x. The value of this angle P is x. Okay, angle P is x. Let PQ is 7 centimeter and QR is 24 centimeters. And we have to find out this to take the values of this sin x and cos x. Why? Because for sin x and cos x both we need hypotenuse. That's why. Here in this given picture hypotenuse is not given. So that's why we have to find out this value. Okay. So here look up here. So from figure, given that the triangle PQR is a right angle triangle. Angle Q is 90 degrees. Angle Q is 90 degrees. And angle P is x. Okay, angle P is x. Here PQ is equal to 7 centimeters. QR is equal to 24 centimeters. First of all, by Pythagoras theorem. By Pythagoras. So PR square is equal to PQ square plus QR square. That is PQ square we don't know, that is equal to PR square we don't know. PQ square is 7 square plus QR square is 24 square. So PR square is equal to 49 plus 20 square 576. That implies PR square is equal to, when you add this 625. So that implies PR is equal to square root of 625. That is equal to PR is equal to 25 centimeters. So here we have to find out, the first one is sin x. What is sin x? According to this P, right? Here angle P is x, hence opposite side QR, hypotenuse PR. So sin x is equal to length of the opposite side by hypotenuse, that is equal to QR by PR. What is QR here? QR is 24 by PR is 25. That's it. So second one is cos x. Cos x means the length of the adjacent side by length of the hypotenuse. According to the x, what is adjacent side? That is PQ. PQ by PR. That is equal to 7 by 25. That's it. Here it is the answer for this question. Next, after finishing this, do this. We have try this. Look at here. Try this in a right angle triangle ABC. Right angle is at C. Right angle is at C. BC plus CA is equal to 23 centimeters and BC minus CA is equal to 7 centimeters. And find sin A and tan B. Okay. So first of all, we have to draw the picture. That is for try this. So first of all, only one sum is there, that is right angle triangle, that is ABC, and right angle is at C. Right angle is at C. AB we can write anywhere. Okay. So the conditions what he was given, that is the conditions was given that the conditions are BC plus CA is equal to 23. Okay. Let us take this one as equation 1, and also BC minus CA is equal to 7 centimeters, that is equation number 2. Okay, equation 1 and 2, add equation 1 and 2. So equation 1, that implies BC plus CA is equal to 23. For doing the elimination, I am taking this as addition. Okay. BC minus CA is equal to 7. So when you add these two, plus CA minus CA cancelled. So 1 BC plus 1 BC, 2 BC. That is equal to, when you add these two, so you will get 30. BC is equal to 30 by 2. So BC is equal to 15 centimeters. BC is equal to 15 centimeters. We just substitute this BC value in equation 1 or 2, anyone. We just substitute this BC value in equation 1. I want to substitute this BC value in equation 1. Okay, substitute BC in 1, equation number 1. What is first equation? BC plus CA is equal to 23. That implies BC plus CA is equal to 23. That implies BC 15 plus CA, that is equal to 23. That implies CA is equal to 23 minus 15. That implies CA is equal to 23 minus 15. Subtract of this one. Okay. So subtract from this, you will get 8 centimeters. CA is 8 centimeters. So now we have CA 8 centimeters, BC 15 centimeters. We have to find out this one. Okay, we have to find out this one. It is a right angle triangle now. By Pythagoras, AB square is equal to AC square plus BC square. AB square is equal to AC square plus BC square. That is, AB square is equal to AC square 8 square plus BC square 15 square. AB square is equal to 64 plus 15 square is 225. AB square is equal to, when you add this, 180, 289. Okay. So when you add this, 289. AB is equal to square root of 289. AB is equal to square root of 17 square. That is, AB is equal to 17 centimeters. Then we have to find out this sin A, right? Sin A. So first sin A opposite side is BC and hypotenuse AB. BC by AB. Sin A means length of the opposite side by hypotenuse, that is BC by AB. That is equal to, what is the BC value? 15 by AB value 17. That's it. The second sum is tan B. The tan B formula is the length of the opposite side by the length of the adjacent side. But according to the B we have to check. According to the B, it is opposite side AC. BC. AC by BC. AC by BC. That is equal to, what is the value of AC? 8 by what is the value of BC? 15. Here we completed this. Try this. Okay. So here there is no units. Don't write any centimeters or meters. Okay, don't write. Why? Because 15 centimeters by 17 centimeters. Centimeter cancelled. There is no units for trigonometric ratios. We just remind, no units for trigonometric ratios. Okay, next in the same page we have think and discuss. Okay, no need to write this one in a notes. Write the answers here itself. Sin x is equal to 4 by 3. Does exist for same value for angle x? No, it doesn't exist. No, it doesn't exist. Why? Because look at here. When you cancelled this, you will get 1.3, 1 point in 3 table 3, 3, 3 and so on. So it is 1.333 is more than 1. But the sign values are in between 0 and 1 itself. The sign values only in between 0 and 1. Hence, it is not existed. No, it doesn't exist. We just write, no, it doesn't exist. Why? Because, why? What is the reason? Why? Because sign values are in between 0 and 1. That's it. Here it is the answer. Okay, look at here. The value of sin A and cos A is always less than 1. Why? Why? Because the quadrants, in the quadrants, first quadrant, second quadrant, third quadrant, when you draw one triangle with 1 unit, then you will get the values of this. That is, in a circle we have, look at here, it is 0 degrees. When you come into the 90 degrees, here 180 degrees, here 270 degrees, here again 360 degrees. So for all the values of this degrees, for all the values of these angles, you will get only 0, 1, in between this 0, 1, minus 1, sometimes it will get minus 1. That's it. So the value of the sin A and cos A is always less than 1. Why? Because in between this 0 degrees to 90 degrees, the values, it gives only 0 to 1. That's it. So here, look at here. Tan A is the product of tan and A. No, it's not the product. It is the angle. Okay. Here the answer is no. It's not the product of, no. It's not the product of tan and A. Okay, tan and A. It is angle. A is an angle. A is an angle. It's not a product of tan and A. Yes. So here we finished this think and discuss. Let us check. Look at here. So in the next page 275 we have try this. What will be the ratios of the sides secant A and cot A? What is the ratios? Okay. So in page number 275 try this. So the ratios of, the first one is the ratios of the sides for secant A is equal to is equal to, secant A means the reciprocal of the cos theta. Okay, cos means adjacent by hypotenuse, but here it is hypotenuse by the length of the adjacent side, the length of the adjacent side. So it is a ratio of hypotenuse and adjacent sides. So just like that, so cot A is equal to, so next in this second sum, that is cot A, cot formula, that is a reverse of this reciprocal of this tan. Reciprocal of this tan means 1 by tan A, right? That is equal to, it is nothing but 1 by tan A means opposite side, the length of the opposite side by adjacent side, that is equal to the reciprocal which comes to up, that is adjacent side by opposite side, that is equal to adjacent, the length of the adjacent side by the length of the opposite side. Okay, hence it is the ratio of adjacent side and, so in page number 275 we have one question, that is think and discuss, that is sin A by cos A is equal to tan A? Let us check. Okay, sin A by cos A is equal to tan A. Look at here, the first question, that is sin A by cos A. That implies, what is sin A? Opposite side, the length of the opposite side by the length of the hypotenuse by the length of the adjacent side by the length of the hypotenuse. That is equal to opposite side by hypotenuse into, when you just take the reciprocal of this one, that is hypotenuse by adjacent side, that is equal to, so hypotenuse cancel, so opposite side by adjacent side, so that is equal to, it is equal to tan A. Here we, yes, sin A by cos A is equal to tan A. Okay, so here we finished the first sum. So second sum, we have cos A by sin A is equal to cot A. Okay, we just do this one. The second sum, we just do this one. Okay, just as usual like this. So after this think and discuss, we have example 1. Look after here. Example 1. That is, if tan A is equal to 3 by 4, then find the other trigonometric ratios of an angle A. Let us do this one. So look after here. Example 1. Here given that tan A is equal to 3 by 4. We know that tan A is nothing but opposite side by the length of the opposite side by the length of the adjacent side. We just draw the figure for this. We just draw one right angle triangle. Okay, right angle triangle, opposite sides, whatever you just take A, B, C. Okay, you just take, it is hypotenuse, it is opposite side, for A it is opposite side, so it is adjacent side. Okay, it is adjacent side. What is opposite side? He was given, that is 3. Adjacent side 4. So you just write here BC is opposite side, no, that is 3 centimeters, and AB is adjacent side, that is 4 centimeters. Okay, hypotenuse we have to find out. It is right angle triangle, hence by Pythagoras, from figure ABC is a right angle triangle. So by Pythagoras, AC square is equal to BC square plus AB square. So AC square is, we don't know. So BC square is 3 square plus AB square is 4 square. So AC square is equal to 9 plus 16. So that is equal to 25. So AC is equal to square root of 25, that is equal to 5 centimeters. Okay, so AC we got here. So we have to find out the other trigonometric ratios. What are the other trigonometric ratios? That is, trigonometric ratios are the first one, sin A. Sin A. Okay. First of all, trigonometric, all the trigonometric ratios I am writing here. Cos A. Third one, tan A. Already he was given this one. So fourth one, cosecant A. That is fifth one, secant A. That is sixth one, cot A. Okay. These are the trigonometric ratios. What is sin A value? That is the length of the opposite side by hypotenuse. According to this A, what is opposite side? According to this A, what is opposite side? BC. BC by AC. BC by AC. BC by AC. What is BC value? That is 3. By what is AC value? 5. 5 by 3. Cos. So adjacent side by hypotenuse. What is adjacent side? AB by AC. What is AB value? 4 by 5. What is tangent value? That is opposite side by adjacent side. That is equal to, opposite side is BC by AB. That is equal to 3 by 4. Already he was given this. Okay. What is cosec? The opposite of sin A. The reciprocal of this sin A. So here it is hypotenuse by opposite side. So AC by BC. That is equal to 5 by 3. That's it. So secant means reciprocal of cos. Reciprocal of cos. You have to reciprocal this. So hypotenuse by adjacent side, that is equal to AC by AB. That is equal to 5 by 4. Here for cot it is reciprocal of tan A. That is adjacent side by opposite side. That is equal to AB by BC. That is equal to 4 by 3. Here these are the values of this trigonometric ratios of this remaining. Okay. So example 2. Next, after finishing this, example 2 we have. In triangle ABC and triangle PQR, if angle A and angle P are acute angles such that sin A is equal to sin P. This is the condition was given, that is sin A is equal to sin P. Then we have to prove that the angle of A is equal to angle of P. Angle of A is equal to angle of P. So first of all we have to draw the two triangles, that is example 2. Okay, so look at here, I am drawing two triangles. That is angle A and angle P. Okay, let us write the remaining as A, B, C, P, Q, R. Just like that I am writing. Okay, given that triangle ABC and triangle PQR are right angle triangles, angle A and angle P are acute angles. Acute angles. Okay, acute angles, and the given condition is sin A is equal to sin P. First of all we will write this sin A. Sin A is equal to opposite side, length of the opposite side by hypotenuse. That is equal to, what is opposite side for this angle A? That is BC. BC by what is hypotenuse? AC. Okay. Okay. I just remind this. Next, just like that, sin P is equal to sin P. Sin P is equal to. Here, look after here. What is opposite side? QR. And hypotenuse is PR. So, just like this. So, here, opposite side by hypotenuse, that is equal to QR by PR. Okay. So, here we have. So, but sin A is equal to sin P. That implies what is sin A? BC by AC. BC by AC. That is equal to QR by PR. Let us take these two values with constant. Okay, this is equation number 1. With constant I am equating these two. Okay, with any constant. Let us assume that K is a constant term which is equating with this 2. We just first equate this one with here 2K and this one. So BC by AC is equal to K. Just like that, QR by PR is equal to K. So you just take this AC into other side. BC is equal to K into AC. Here also QR is equal to K into PR. K into PR. You just remind these two. Okay. Next, from looking these two triangles, we have a right angle triangle. By Pythagoras, I am writing the equation. By Pythagoras, from figure. So, AC square is equal to AB square plus BC square. Just like that, from the triangle, PR square is equal to PQ square plus QR square. Okay, so we know, look at here, we have to make the BC by AC, means BC by AC, and QR by PR. We took here, look at here, BC by AC is equal to QR by PR. What we have remained, that is AB and QP. AB and QP. In this AB is there, where? This one. This one. Okay. So AB just remained same as, you just bring this BC square into other side. That is AB square is equal to AC square minus BC square. Okay. By using of this Pythagoras theorem, what we have to remind here? So here we took BC by AC, QR by PR. So in this triangle, AB we didn't use, the third side of this triangle. Just like that, QP we didn't use in this triangle. Okay. So if we are equating these two also, then the two triangles which are similar. The third side, the corresponding, all the corresponding sides has to be, if all the corresponding sides are 0, that is corresponding sides are equal, then these two triangles which gives the similar properties. Hence, then after we will then after angle A and angle P, which makes the acute angle, which are same. That's what I am proving here. Okay, AB square is equal to AC square minus BC square. AB is equal to square root of AC square minus BC square. AB is equal to square root of AC square minus, what is B from this? K into AC. K into AC whole square. Okay, so AB is equal to square root of AC square minus K square into AC square. Okay, AB is equal to square root of AC square, I am taking it as common, 1 minus K square. AB is equal to square root, I am separating for these two, so 1 minus K square. So AB is equal to AC square root of 1 minus K square. I just take it as equation 2. Just like that, you just prove this one also. Okay. So what we have to remind? PQ. Okay, we just take this one into other side. Then PQ square is equal to PR square minus QR square. So PQ is equal to square root of PR square minus QR square. So PQ is equal to square root of PR square minus what is QR? K into PR. K into PR whole square. PQ is equal to square root of PR square minus K square PR square. PQ is equal to square root of PR square I am taking as common 1 minus K square. PQ is equal to square root of PR square root of 1 minus K square. I am separating these two. PQ is equal to square root cancel PR into 1 minus K square. This is equation number 3. Okay. So this is equation number 3. And let us equate these two. Okay. I am taking equation 2 by equation 3. That implies what is equation number 2? AB is equal to AC into 1 minus K square. AB is equal to AC of 1 minus K square. Just like that. 3. What is 3? PQ is equal to by what is here? PR square root of 1 minus K square. Equation 2 by equation 3. Equation 2 by equation 3. That implies AB by PQ is equal to, here these two are cancelled, AC by PR. Okay, here look at here. So we have BC by AC is equal to QR by PR. So QR by PR. Here AC by, so you just take this one AC into this side and this one into other side. So AB by AC is equal to PQ by PR. So from this is equation number 4. From this equation number 4 and the above condition, all the corresponding sides are equal. That implies AB by AC is equal to, look at here, corresponding sides are equal, no? So AB by PR, look at here, AB by PR, corresponding sides are equal, no? Here AB by PR is equal to BC by QR. BC by QR is equal to AC by PQ. AC by PQ. So therefore triangle ABC is similar to triangle PQR. Hence angle A and angle P are acute angles. That's it. Okay, here we finished this. Sum. Okay, so here he was not given in the elaborate way. You just look after the sum and do in a proper way. Okay, so here we have example 3. Example 3. So let us check. Consider a triangle PQR. Consider a triangle PQR. That is at right angle is at R. Right angle is at R. Okay. So I am drawing one right angle triangle and right angle is at R. P and Q we can write anywhere. Okay. In which PQ is 29 units. Okay. So QR is 21 units. QR is 21 units. So and triangle PQR is equal to theta. And triangle PQR is equal to theta. PQR means this one is theta. Okay, this one is theta. Find the values of some values we have to find out by using of this values. Okay, so angle PQR is equal to theta, means angle Q is equal to theta, the middlemost term, that is Q. Angle PQR means the middlemost, that is Q. Angle Q is equal to theta. Okay, so by using of this theta we have to do this sum. First of all, given that triangle PQR is a right angle triangle. Right angle triangle. Right angle is at, so angle R is equal to 90 degrees. So angle PQR, that is equal to angle Q is equal to theta. Angle Q is equal to theta, and PQ is equal to 29 units and QR is equal to 21 units. First of all, we have to find out this PR. PR is equal to how much? Okay, by Pythagoras. By Pythagoras. So we are taking this equation as PQ square is equal to PR square plus RQ square. Okay. So PQ square we know, that is 29 square, is equal to PR square we don't know, that is PR square plus RQ square is 21 square. That implies 29 square is 841. PR square we don't know, plus 21 square is 441. That implies PR square is equal to 841 minus 441. That implies PR square is equal to 400. That implies PR is equal to square root of 400. So we can write this 400 as 20 square. Square root cancelled. That is PR is equal to 20 units. Okay. PR is equal to 20 units. We got this PR value also. Now it's time to solve the sums. That is cos square theta. Cos square theta plus sin square theta. Okay, that implies cos means adjacent square, adjacent by hypotenuse square, plus sin means opposite side by hypotenuse whole square. Okay, so what is cos theta? For cos theta, what is adjacent side? QR. What is hypotenuse? PQ. Okay, so QR by PQ whole square plus, here what is opposite side? RP. So PR by PQ whole square, that is equal to, what is QR? That is 21 by PQ. What is PQ? 29 whole square plus here PR, that is 20 by PQ, 29 whole square, that is equal to, so square, so 21 square means 441 by 841 plus 20 square means 400 by 841. So square for both the numbers, that is equal to LCM of this one 841. So both the denominators are same we have to add for the numerators. That implies 841 by 841. When you cancelled this, the value you got, that is 1. Okay. So next, what is there? So in the second sum, no need to write all the values of this one. Okay. So cos square theta minus sin square theta. In the first sum itself, we did the values of this cos square theta and sin square theta. I am taking these values. Okay. So the value of this cos square theta I got 441 by 841 minus here 400 minus 841. Here in the first sum, he gave plus in between these two, and here minus in between these two. Okay. So look at here, that is equal to LCM of this one, that is 841. 441 minus 400, that is equal to, when you subtract this, 41 by 841. It is the final answer for this question. So here we have the solution of this question. Up to here I finished. And the next part I'll explain this exercise 11.1. I think you should understand this examples. All do this, try this, and before the sums of this 11.1. So let's watch the next part of this trigonometry. Thank you.